Okay, now on to the next group of Calliphoridae species. These include a lot of several of the common species that we see at different times of the year and that we know quite a bit about. That first species is Phormia regina. You also might see or hear people call this Phormia regina, but the way that is made makes me giggle because it sounds like vagina, and that's hilarious. And it's never good for me to sit on the stand and just giggle like a 12-year-old. So I call it Phormia regina. You say it however you want. Now, this is commonly known as the black blowfly or the black-legged blowfly. This is found throughout the U.S. It is very common, with the exception of the southernmost tip of Florida. We just don't see it down there. Weird. Okay. So this ranges from about 7 to 9 millimeters in length, and it's a very dark green to olive colored fly overall. So you can see it's got this dark green coloration, but I'm going to keep harping on this. The overall body color really isn't the best way to tell the species type. This gives you a clue as to what it might be, but there is variation within this coloration. That's why I say dark green to olive. You know, it's kind of bad to me. Well, it's sort of this range of color. So whenever you see something that is sort of greenish, you're going to want to have other non-changing characteristics other than that overall body color to tell. Now, this is one where the head kind of looks metallic from far away, but it's not that bright green metallic. Okay, so keep that in mind. Now, this is called the black-legged blowfly because the legs tend to be black, except right at the top here where they have this olive metallic coloration. So black legs, black-legged blowfly. Now, the major characteristic and the major rule of thumb for this particular species is the anterior thoracic spherical. This spherical right here, it has bright orange hairs. So if it's got a bright orange anterior thoracic spherical, tends to be overall olive in coloration, it's got these black legs, and its genna or its cheeks are black, those are the rules of thumb for Phormia regina. So bright orange spherical, black cheeks, black legs, you've got a Phormia species. Really, there's only one Phormia out there. It's regina. So there you go. Now, this is typically a cold weather fly. This is most abundant in the south during spring and fall. Although it is a summer fly as we get more north. So in those areas where we have very cool summers, very harsh winters, this is a summer species, and it becomes spring and fall or maybe winter as we get south into the really, really warm areas. Now, the larvae develop on carrion, on a regular basis. We don't tend to see them on, say, fecal material or anything like that. These are known to produce myiasis, at least secondary myiasis. They do not show up on organisms and feed on the living tissue. They only feed on the dead tissue, at least that we know about. So this species we know a lot about because it is so common all throughout the U.S. I will see this early on in the spring, later in the fall down here in the south. And so we do have a lot of information on how long this one takes to grow. So it is also really easy to identify because of that bright orange prothoracic spherical. So you can tell this in the adult stage, at least, just on sight pretty easily. It's a little harder in the maggot stage. There are a few characteristics that you have to go through, but I'll tell you about those in a few weeks when we go over identification. So this is Phormia regina. Chrysomya rufifasces. This is the second species that I spent a whole heck of a lot of time looking at in my PhD because this is an invasive species. So this is known as the hairy maggot blowfly. That's because of the way that the maggot looks. So remember I was talking about most of these maggots are smooth maggots. They are creamy white in coloration. This is one of those exceptions. Notice how sclerotized this maggot is. And it's got all these fleshy protuberances, all these really, really thick spikes all over it. This is why we call it the hairy maggot blowfly. This is a pretty hardcore maggot. If you were to pick one this up, it feels spiky and it's really, really rough. So it is indigenous to the Australian and Oriental regions of the world. It's in the tropical regions of those areas. And it was introduced in the U.S. in 1991. It is now well established throughout the South. It was all over. It came in through, I believe, Texas, moved into Florida, and now it has moved northwards. Now, it has drastically expanded its range. Most recently, it's been found up through southern Canada. So even though it's a warm weather fly, warm region fly, it has moved into these cooler regions. It only makes it up there during the warmest months of the year, though. So you will see a few papers from throughout the U.S. saying, oh, we found this is the first record of Calliphoridae rufaces in this particular region. The more northwards it goes, the more restricted its time is. It's only there like the peak of summer or really, really warm times of the year. Now, the adults of Calliphoridae rufaces are stout. They're sort of a brilliant blue-green body, so they're very, very shiny, really pretty, like that. And they've got these dark blue tinged abdominal segments, so they're super shiny. And they've got white cheeks and usually a white or bright white prothoracic spherical. Now, they're easiest to identify in the larval stage, though, because they are spiky. They're hairy, if you will. And you can see those spikes left over on the pupa, because remember, in the Calliphoridae, that pupal casing is just made by that last instar integument. So those hairs or those spikes are readily available, or they're readily seen there. Now, these may be one of the first to arrive in carrion when they are found in the area, but they very rarely enter dwellings, and they develop only on carrion, not on excrement or other decomposing material. Now, this is an interesting species because while I say it may be one of the first to arrive on carrion, there's also some evidence that it does wait. It can delay its arrival between 24 and 48 hours. So it doesn't show up immediately on carrion all of the time. So it's a weird one. And this is one of the reasons I studied it in my PhD, is because the larvae are both predaceous and cannibalistic. So these larvae, when they are really young, when they are in their first instar, they are kind of hard to tell from smooth maggots. Those protuberances, those little spikes, are kind of hard to see when they're really, really young. And so they will get into other maggot masses. They will feed in those maggot masses when they're little, but as they get bigger, they're going to sclerotize their body and they're going to sclerotize their mouth hooks, and they become predaceous. So they will consume and often totally eliminate other species on the carcass. So this is a fascinating thing to watch. They will show up on these bodies, they will be in this maggot mass, and as they get older, instead of just feeding on the carcass itself, they will feed on whatever other maggot they run into. So in the lab, because this is what you do in grad school, we actually would have fights with maggots, and we would put these hairy maggot blowfly in with other smooth maggots, and we would just watch them fight. And what would happen is this maggot would come along and it would run into another maggot in the maggot mass. So especially in the third instar, they became ridiculously predaceous. So they would run into another maggot with their mouth hooks, and they would grasp onto that maggot with its mouth hooks and curve its body around that maggot, and it would pierce those smooth maggots and feed on the hemolymph in those maggots. And so no matter what maggot it ran into, it could be a heterospecific maggot, so a maggot of a different species, or it could be conspecific. It could be another Calliphoridae rufaces. It would still fight those maggots, so it would be cannibalistic. It would feed on whatever it would run into. There it would be, and it would feed on it. Species that have evolved with this maggot, like another maggot that I'll show you in a minute, they've actually evolved this method of getting away from this predaceous maggot. So if something runs into another species that evolved with rufaces, that other species will sort of shorten and do this weird barrel roll type thing. It would just roll away. And so these rufaces would have to chase it. But because it is invasive in this area and has only been around for a few decades, really, The species here haven't gotten used to it. So poor Macellaria. Oh man, Macellaria are like the perfect prey for Chrysomya rufaces. So Macellaria, they show up in large numbers. They're really big maggots. They feed voraciously, and these predaceous maggots then would come after them, and Macellaria doesn't know how to roll away. And so it just gets decimated. So there have been times when I have seen an entire body covered in Rufifaces with maybe one or two teensy tiny little patches of Macellaria left behind. So that's indicative of Macellaria being there, Rufifaces showing up and just feeding on all the Macellaria that are there and getting rid of it. So this can actually cause a bit of a problem when it's on a body. Also, if you are transporting live maggots for one reason or another, if Rufifaces is there, you want to make sure you do not put Rufifaces in the same container as any other maggot, because it'll just eat it. Now, it will eat each other too, but it'll be the survival of the fittest and a few will be left behind. So if you are, say, sending me live maggots, make sure there is no Rufifaces in there, because Rufifaces will just be the only thing left behind when it finally gets to me. Now, it has a significant impact on the native species like C. macellaria. So we've had a few indications that Macellaria is going to be outcompeted in some respects, and we do see Rufifaces just taking over bodies. However, Rufifaces does not handle water very well. So in areas where it's raining a lot, where we get a lot of standing water, Macellaria will outcompete Rufifaces because Macellaria just won't drown. Remember last time I talked about how Macellaria is found in these big pools of water. You know, you get these almost totally submerged bodies. Macellaria are happily floating around, swimming, and still feeding. Rufifaces can't do that. They will die. So I've seen a bunch of dead Rufifaces after massive rain events, and Macellaria happily feeding. Now, Rufifaces will colonize buried remains if the remains are buried very shallowly and it's not overly saturated with water. So we're watching a neat competition happening with this species. One species that did evolve with Rufifaces is closely related. It's another Chrysomya species. This is Chrysomya megacephala. This is widely distributed throughout Oriental regions, throughout South Africa, throughout South America. It is another invasive species in the U.S. It is well established in the southern U.S., particularly in Florida, Georgia, Alabama, Mississippi, Louisiana, and southern Texas. It hasn't made its way up north, though. It seems to like the really, really hot regions. Now, this one can be very easy to tell on sight simply because of its adult body form. So the adults have these short, stout bodies that are similar in appearance to Rufifaces, but it has this really large head. So if you see sort of this greenish blue fly, very shiny with this huge head and a rounded butt, that's going to be megacephala. So you can see these just sort of landing on a body, big old head, round body. You've got megacephala. Pretty easy to tell. And when you see these flying around, you're like, oh, look at the adorable megacephala. Especially the males. I mean, look how huge those eyeballs are. Females, the eyes are going to be a little bit smaller, but they still are very, very just short. They have these short bodies. Notice they do have or can have these orange cheeks, but they don't have vitty. So they're not Cochleomya macellaria. Okay, so the eyes, especially in the males, are a very prominent shade of red when they're alive. Look how bright those things are. Once they're dead, they kind of lose that coloration, but bright old red eyes when they're alive. Now, both the males and the females are attracted to carrion. They're also attracted to fruit and sweet foods, and they can land on fecal material, hence the common name of the latrine fly or the oriental latrine fly. So they do show up on poop. We see those a lot on fecal material. Okay, now it has, the megacephala has pronounced peak activity during the heat of the afternoon. So it likes it really, really hot. But it is one of the first to become active in the early morning hours and one of the last to depart carrion at night. So while we see it's most active during the hot times of the day, it is able to get going when it's a little bit cooler. Now, it is often one of the first to show up on carrion in the areas where it's very, very common common. In fact, in southern Florida, we do tend to see this in marine areas, so that's unusual. Used to be not a lot of flies would show up on bodies that were near the ocean, but Megacephalus seems to be able to handle that salt for some reason. We actually really need to look into that, see what's going on there. Now, once the adults have settled on carrion, they are not easily disturbed. So they will just sort of sit there and you can walk by, they won't flit away. So it is possible to collect the adults from remains, even if they are they're in very low numbers, because other species will fly away very, very quickly. Now, these species also readily enter dwellings to find food and oviposition sites, so we can see them indoors or inhabiting bodies that are indoors where they're in range. Now, the larvae are smooth larvae, so they're very easy to tell from the Rufophases, but these larvae have evolved with Rufophases, so these are the ones that will do sort of a barrel roll away as Rufophases show up. They're in the same genus, so they know what they're doing. But the larvae are primarily carrion feeders, and the adults do show preference for fresh remains, although we can see them on fecal material. All right, so that's it for this group of species. Let me know if you have any questions.